viewers, you are welcome to ChemTeach Arena with Master Delight. Today we are having some questions on salt hydrolysis. Salt hydrolysis. Salt hydrolysis. So we are having some questions on salt hydrolysis. And the question is this: which of the following salt is acidic, alkaline, or neutral? So A, we have Na2SO4. This is sodium tetraoxosulfate 6. This one is Na2CO3. This is sodium trioxocarbonate 4. This one is CH3COONA, which is a sodium ethanoate. This is an organic compound. A and B are inorganic compound. The C is an organic compound. Now, when answering questions on salt hydrolysis, please make sure you get used to this table. Please, it's very, very important. I want you to memorize this table. I want you to know it offhand. Memorize it and know it offhand. Now, this table actually explains questions on salt hydrolysis. Make sure just the way the periodic table is very important, just the way the electrochemical series, which is activity series, is it's another important table. So same way this chart or this table is as well very, very important. Please, I am begging you just memorize it for your exams, because these questions, you see them in WAEC, you see them in ECHO, you also see them in JAM. Okay, now we have this table goes this way. We have SA. SA means strong acid versus weak base. This is strong acid, this is weak base. Then whenever you have a reaction that involves strong acid and a weak base, the pH of that solution is going to be what? Less than 7. The pH is going to be less than 7. Now, when a pH is less than 7, we say that solution is acidic. When a pH is 7 on the dot, we say that solution is neutral. Then when a pH is above 7 to 14, we say that solution is alkaline or basic. Now, what is pH? pH is the measure of the acidity or alkalinity of a solution. What I mean is that pH helps to determine the extent of how acidic or alkaline a solution is. Because you might be given a solution in your chemistry laboratory, they will now ask you, identify or tell us the pH range of this solution. pH range tells you if that solution is going to be acidic, or if it's going to be alkaline, or it's going to be neutral. Example, you have water. Water has a pH of 7. So that 7 makes that water to be neutral. It's not acidic, it's not basic. So it's neutral. Then if they give you acids, maybe H2SO4 or any of the acids, the pH is going to be less than 7. It's going to be acidic. So when they give you base, such as maybe potassium hydroxide, sodium hydroxide, and all of that, the pH is going to be higher than 7, which tells you that this solution is what? Is an alkaline. So strong acid, example of strong acid, we have what? Strong acid, we have HCl, HNO3, H2SO4. These are strong acid. Then weak base, we have ammonium hydroxide. It's a weak base. We have ammonium hydroxide, even group 2 elements, calcium CaOH2. So calcium hydroxide, they are weak base. So whenever you react this acid with a weak base like this one, we are going to have a solution you are going to have an acidic solution. That means the pH is going to be less than 7. This is less than, this is greater than, less than 7. So strong acid again versus strong base. Strong base example is KOH, NaOH. Let me go with that too. So they are very strong bases. KOH and this. Strong acid, the same thing as strong acid. So strong versus strong, the solution is going to be neutral. This is weak acid. Weak acid such as H2CO3 and CH3COOH. I just gave the trioxocarbonate acid and the ethanoic acid. They are both weak acid. Then weak base, I've given you weak base here. Weak base, I gave ammonia and this. So whenever you have this reaction, you are going to have what? The solution is going to be neutral. Now take note, strong acid versus strong base, the solution is going to be neutral. Weak acid versus weak base, the solution is going to be neutral. The pH is going to be neutral. Then your major constant focus now is going to be strong acid versus weak base, and weak acid versus strong what? Strong base. If it is strong base, the solution is going to be alkaline. It's going to be greater than 7. You know pH ranging from 1 to 14. This can be scary. So pH ranges from 0 to 14. 7 here is neutral. This is the neutral. So from here go up like this is what? Alkaline or basic. While from here from 7 coming downward to 0 is what? Is acidic. Is acidic. So that this is pH meter. So this is for this and this you have this. Do you understand that? Fine. I'm trying to rush it a little so that I can manage the time. So now let's quickly answer the question. Na2SO4. Now, how can we know if this pH is even here or it's not there? So this is what we do. Then which acid is here? Which acid is here? Pick the acid here. This is H2SO4. Just pick it. Yes. If you have seen NaCl, they now ask you, just pick HCl. If you have seen NaNO3, which acid is here? Just pick HNO3 as the acid. Do you understand? Fine. Now let's pick this one now. I pick my acid. My acid is H2SO4 plus. I pick my Na. Whenever you see Na2, take it as NaOH. Yes, that is the base. So what do we do now? We now write, we get our Na2SO4 plus what? H2O. This is the equation that formed this one. Is it balanced? So we have to put 2 here. We have 2 here. So we have 2, 4. 2. Okay, 2 will come here. 4. So I think the equation is balanced like this. So you identify your states, aqueous, then liquid. So this is the equation now. You see, this salt is this number 1 salt. This is just what I want. Now, what reaction forms this? We have what? Strong acid. We have strong base. This is strong acid, this is strong base. What is it? That means this solution is what? Is neutral. It's neutral, and the pH is equal to what? 7, because pH of 7 is neutral. So the answer to this first one is that the solution is going to be what? Is going to be neutral to litmus paper according to salt hydrolysis. Is that clear? If you dip your litmus paper, it's going to be neutral to litmus paper. That's why I'm using what? Neutral pH is equal to 7. Then let's quickly look at the second one. You can pause the video and try the second one if you can get the correct answer. Then for the second one, B is what? Na2CO3. Which acid even have this CO3? Because we already have sodium here, sodium hydroxide here. You can say whenever you say Na2, you take sodium hydroxide. So which acid have CO3? Look at it. This carbonic acid, H2CO3. Then I'm going to write my H2CO3 is a weak acid. React with what? NaOH. NaOH is a strong base, so you already know the answer. This one will give me Na2CO3 plus H2O. I have my liquid, I have my aqueous, Then my sodium is 2 here. My sodium needs to be 2 here. Sodium is 2. So oxygen, what oxygen is? Okay, my hydrogen is even 4, so my hydrogen is 2 here. So I have 2 plus 2, that is 4. I have 4. Oxygen is 2 plus 3, that is 5. 2 plus 3, that is 5. Carbon is 1. Sodium is 2. So my equation is balanced. So now this is my weak acid. This one is weak acid. This one is a what? Strong base. Go to your table. Weak acid versus strong base. Weak acid versus strong base is what? Greater than 7. So this one is what? It's going to be alkaline. It's going to be alkaline. pH is greater than what? 7. Then for the last one, which is C, what do we have as C? We have CH3COONA. Let's have our I already have Na. I've told you whenever you see Na2 or Na, take it as sodium hydroxide. Then CH3COO. Look at this acid. CH3COO. This is ethanoic acid. So it's a weak acid. CH3COO. I don't know if you can see the dot from there. Okay, let me write it off. I can erase there now. So for the acid, for this third one now, this is where I am. Then I have my CH3COOH, that is ethanoic acid. This place will affect me. CH3COOH, this is ethanoic acid, plus Na. I told you put NaOH, that is sodium hydroxide. So aqueous, what will I get? I'm going to have CH3COO, CH3COO, Na, then plus what? CH3COO, Na plus H2O plus H2O. Some of you might not be familiar with this equation. This is esterification anyway. Now, this is it. CH3COO minus, hydrogen is plus. This is the basicity. This is the ionic equation that will give you the basicity. The basicity of this acid now is just 1. So sodium, write the equation for sodium, Na plus OH minus. This is my big plus, which is this plus is this plus. I've broken this one down, I've broken this one down. The reaction is actually a reversible reaction. Then, you see this CH3CO minus, it will migrate to this, it will pick this one. This one will pick this one. It will now give us what? CH3COONA minus plus, unlike charges attract. Why this H and OH will give us H2O? That is how I got the equation. I just broke this one down into its ions. CH3COO minus H plus, Na plus OH minus, plus compo minus, plus O2 minus. So it will give you water. So my aqueous liquid. Is the equation balanced? Let's just check. See, hydrogen is 4, 5. Hydrogen is 3, 2, 5. Carbon is 1, 2. Carbon is 1, 2. Then oxygen is 1, 2, 3. Oxygen is 1, 2, 3. I think sodium is 1, sodium is 1. The equation is what? Is balanced. Now check. This is a weak acid. Weak acid. This is a what? Strong word base. Weak acid versus strong base is still what? Same thing as alkaline. The solution will be alkaline. Then pH will be greater than what? 7. So this is the answer to this question. I hope you were able to learn something from this explanation. If you do, please subscribe to my channel and share my videos. And may you remain blessed while you do that. Thank you.